Let's take a look at logarithms, example 4b. You see it on the screen. Again, you have all these have been sent to you. Pull them up, print them if you're able. So here's the deal again, and we're giving you ones that are conducive to straightforward algebra. You'll notice that the variable x that we're supposed to solve for is in one place, and that will be the case on all of these. And so again, that inverse operation approach would be the most logical way to attack it, whereby we say in the order of operations, which of those operations is furthest down the list from x. And so year after year I ask people, what do you think would be the furthest operation from x? And the subtract 7 seems to jump out, I would hope, right? That's the furthest from x. So we introduce addition to get rid of that 7. These seem to be some of the preliminary steps that should be familiar to us by this point. All right, and then again, when you recite the order of operations here, you would hopefully realize that multiply by 4, again, we're just kind of doing this in reverse order here. And so you get rid of that multiply by 4 with divide by 4. And that will leave us with e to the 2x plus 9 power equals 7 1/4. Is that what that is? Sorry, I'm just waking up here. 29 divided by 4. Why can't I do that in my head? Yes, that is 7 1/4. Okay. And then, now, here's the step that would be new to us. So we got rid of the subtraction, we got rid of the multiplication. Now you're up here, and you think, well, wait, exponent logarithm. Well, here's where the new bit of recognition needs to take place. In looking at this, I hope you would notice that the e seems to be the furthest operation from x. And what you need to recognize is that the role that the e is currently playing is that it is a base. We want to get rid of that e, and it's a base. And that would hopefully conjure up to us the idea that the equation that's on the board right now is what would be considered an exponential type of equation. We have a base raised to an exponent equals something. And so therefore it resembles that exponential pattern. And so that would hopefully be the point where you would say, we need to get rid of that exponential equation that we currently have by changing it to logarithmic. See, exponential and logarithmic are inverses of each other. And so that would be hopefully what your mind would notice. And you'd say, I'm going to change that exponential to a logarithmic, much like we did on examples number 1 and 2. All right, so you go log, base, and you come over here and you see the base, and you notice it's an e, and you start to write log base e, and this is the point where you're supposed to go, you bad hand, log base e, wait a minute, there's a special symbol for that. When you have a log that's base e, that's called a natural log. So there's really not a symbol log base e. Log base e is actually natural logarithm. All right, so that takes care of the fact that the base was e. Again, we're changing this over to the logarithmic expression. So that takes care of the fact that the base was e. Following the pattern that we practiced, go back and review examples number 1 and 2 if you need to remind yourself how to go back and forth, how to convert exponential to logarithmic, and vice versa. But this would be log base e, otherwise known as natural log, of 7 1/4 equals 2x plus 9. And then the nice thing about the natural log of 7 1/4 is that there's a calculator function for that. That's one of those special ones that gets its own button. So we can just put in the natural log of 7 1/4. I'm hitting that button that says ln, and then putting in 7.25. And so in a calculator, this becomes 1.981001469. That's just putting that in the calculator. And that'll be approximately 2x plus 9. And then finishing it out should be easy at this point. I hope you all would understand now that we should subtract over the 9. That would be the next step. And so that 1.9 number minus 9. And I painted myself in a corner here. I should have brought this up higher, but I wanted this to be next to this so you could see the changeover. So that's now negative 7.018998531 is approximately 2x. And then of course you all know that finally to get the value of x you would divide by 2. So you introduce divide by 2, and I believe the instructions, if I'm not mistaken, were 4 decimal places. So let's transfer our answer up here somewhere. X ends up being approximately negative 3.5095. And there you go. So again, that was using inverse operations to isolate a variable, and remembering that the inverse of an exponential equation is a logarithmic. We will continue practicing. Good job, everybody.